This is Michael Wentworth-Bell from Real Pictures. Real Pictures is a 3D animation studio located in Melbourne, Australia, and we've recently used RealFlow extensively in a 10-minute 3D animation for a permanent installation at the Perth Mint in Australia. This here is one of the sequences from the animation. The project is called The Wonder of Gold, and the animation follows the story of gold throughout history. This sequence here is from the beginning of the animation, focusing on the origin of gold. The Incas believed gold to be the tears of the sun, and the Egyptians called gold the rays of the sun infused with water. The animation has been designed for a wide 12-meter width by 1.8-meter height wraparound screen, and it was displayed using 5 video projectors. In this video, I want to give an overview of how we created the magic water effect here. This was done mainly using the D-spline daemon in RealFlow. I also want to give an overview of our workflow on this scene. I'm not going to give a step-by-step walkthrough of every button that we pressed, but the D-spline daemon in particular will be covered in depth. But if after watching the video you'd like any further information on anything covered here, do get in touch and let us know. Firstly, this is a look at our 3ds Max scene for this particular shot. Our 3ds Max scene was used first to do the layout of all the objects, camera, animation, and our timing. These objects were then sent to RealFlow, and after the simulation, the mesh here was sent back to 3ds Max, where we did our shaders, lighting, and rendering. The shot involves a transition between the tears of the sun and the rays of the sun, and so both those kind of sequences were in the exact same Max file, and we did that using state sets. We had one state for the face scene with the tears and the other state for the sun and the water, and as I switch between the states here, state sets is changing our render settings like the range and a couple of the quality settings, output paths. It's also changing layer and object visibility. It can record changes to shaders, just about any different change that you do in 3ds Max. When we were doing the layout, the number one thing that we had to make sure of was that the ultra-wide aspect ratio, which is actually 20:3, worked well with our animation. And so to do that, we first created a helper object, which was basically a rough geometry shape of where we wanted the liquid to go. This green shape here is our planned path, and you can see the liquid pretty much followed it in the end. So this was just an editable spline, and the spline had a few different control vertices, control points, and we just positioned the spline exactly how we like it in the scene. This was really helpful because, as you'll learn later, if you haven't used a D-spline in RealFlow before, it can be a bit finicky and difficult to work with. But basically this way we were able to set up where we wanted the animation of the water to go through in our scene, and to make sure that the water passed through certain rays, which would create a splash with the water and break it up in interesting ways. That way we're also just able to confirm our timing and animation and everything was going to be right. We could then send all of this to RealFlow and have a guide for not only the D-spline but where we should put the control points of the D-spline to match our shape. So with all of this set up, the basic animation, collision objects and the spline, we sent this information off to RealFlow using the RealFlow connectivity plugin. Here is our RealFlow scene for this shot. In this video tutorial, I'm going to focus mainly on the D-spline. Everything else in this scene was fairly standard. The kill volume, normal amount of gravity. An important setting is obviously the geometry scale. In 3ds Max we're using centimeters, and in RealFlow we're using meters. And so to be completely accurate, our geometry scale should probably be 0.01. But in our case, we found that 0.1 looked fine for the fluid. The geometry scale can affect, obviously, the amount of force and gravity and the scale of the fluid. So all of your settings depend on your scale and your scene size. But let's have a look at the D-spline here, and you can see that this is our line from 3ds Max, and our D-spline follows the line perfectly. So that way we were able to just make sure that the fluid followed the exact path that we were after. This control points of the D-spline were placed at the same vertice points of the original reference line. We've added a few extra control points to our D-spline along the way to just change the settings a bit. Basically, here are the settings for a D-spline. And so, in a nutshell, the D-spline has got three main strengths. There's a vortex, which spins particles around either clockwise or anti-clockwise. In our case, we've given it a negative value, so the D-spline is going to spin the particles in the opposite direction to what they would have been spinning. The axial strength is going to push particles along the direction of this white main spline that makes up the D-spline. So if you have an axial strength of 1, it's going to push it this way, and if you change it to -1, it'll push particles in the negative direction. Finally, the radial strength is a strength that controls how much particles are pushed towards the middle of this spline here. So by looking at the D-spline from this angle here on the side, a high radial strength will mean that particles are pushed right in the middle and they can't really escape with the vortex to the very outer edges of this circle shape here. If you have a low radial strength, then particles can kind of spin further and further away from the center of the D-spline. And if any of these three settings are too low, then your particles will fall off the D-spline. And so you can see in our simulation here, plenty of particles have fallen off the D-spline. Here, they pretty much stay within the D-spline along the way. You're losing a couple. But here, if I look here from a top view, this is an overhead view. We've got the particles going here, and then there's a massive turn where they need to go back up again. And looking at that in a perspective view, as well as turning at a really sharp angle, they're actually also rising up. So gravity is going to be naturally pulling them down, and the force from the D-spline is going to push them that way. And so in this case, we've lost a lot of particles as they fell off the D-spline. So there's ways to control that, and depending on the look you're after, you might want particles to fall off the D-spline, or you might want them to be perfectly attached to the direction of the D-spline itself. After setting the main, as well as these three main settings on the D-spline here, going into edit mode allows you to click on any of these control points of the spline itself. You can move them around and position them, but as well as movement options, you've also got controls here to set the axial strength, radial, and vortex strength on a per point basis, which in most cases with a D-spline, especially in our case, you have to do that. And so, for example here, we've got a radial strength of 2. So the strength pushing the particles in the center is 2, and up here, the radial strength is 3.85, so it's almost double at this point. And so that's why when we look at the particles here, they can spin around a lot, but when it gets to this corner here, I want it to turn left and duck down and dive back, so you want them to be closer to the center of the D-spline. If the radial strength was still 2 at this point, they might be out here and some of them might trail off that way. Likewise, as we get to the lower point of the D-spline here, you want to have a higher axial strength up here so that it's going to pull the particles up along the direction of the spline. So here we've got an axial strength of 1.3, and then by the time we get to here, it's still about 1.2. Here it's only 1, so that you kind of want to slow down a little bit and then speed up again. So these individual options here let you control any part of the D-spline you want. You can have the vortex spinning particles a whole lot here and have a really low value here, so they won't be spinning around at this point. So to explain how that's actually working, if I set the radial strength to be 4.3 for this control point, and in this control point the radial strength is only 1.5. Those are the actual force values for this D-spline, and up here these global values are multipliers. So I've got a radial strength of 1.5 and the multiplier is 2.2. So that means the final value is going to be over 3. So 2.2 times 1.5. And so these multipliers are a great thing to sort of set a basic look for your D-spline by putting in your values, so you can kind of set your rough speed, and then you can go in and tweak it to make it look exactly right, and finally come back, and here you can just set your global multipliers. So in our case, for an example, the axial strength, which controls how fast the particles move along the white main shape of the D-spline, we thought it's pretty good, but it would be great if it was just a little bit slower. And so by changing that value down to 0.85, overall, the entire D-spline axial strength was a little bit weaker. That's our D-spline there, and I thought I'd just quickly give an overview of the D-spline itself when you're making one from scratch. It takes a fair bit of time to put one together exactly how you like it. But basically, when you make a D-spline, you can select it here or select it in your relationship editor. And rotating it, moving it, and scaling it will scale the entire spline as one. Then, if you want to control individual control points, you hit Edit. So the first step is to put the D-spline exactly where you want it to fill up. So if it's going to be over there where the sun and rays are, you'd put it in the rough position first and then start tweaking. Then you hit Edit mode and you're able to select individual control points. When you're in edit mode, a really annoying thing, as of RealFlow 2013, is that you can't undo movements made to individual control points. So here, I move the point over there, and I've hit undo. You can see I've tried to undo it here, but it didn't move back to its original position. So when working with the D-spline, generally you should save your scene, make your changes, save it, make changes, and if you make a really bad mistake where you accidentally move it way off into infinity, you can revert to an earlier save file, because otherwise you're going to have to move it back or enter values. A really great tip is that when you're moving these nodes, you can actually link any control point to any object in your scene. So let's just say I've got a sphere. I'll bring it here. Now this is a sphere made in RealFlow. Imagine if this was a sphere that came from Max, or any object, a helper object, and it had an expression on it to control random movement, or you had actually animated that over time. Well, I can position this sphere where I want it, select this individual control point here, so I'm just going to make sure I'm only got the one control point. What I can do is go to control point link, and from this list, if I select that sphere I've just made, now the control point is moved to the position of the sphere, and it's also parented to it. So I've got the sphere selected now. You can see here in my relationship editor, I'm affecting the sphere, and when I undo the sphere's movement, obviously the D-spline will undo as well. This is a great way to control the D-spline. With the D-spline selected, you can also insert control points, and it'll add a control point after the current one in order. So they've got an index here. This is 1. The one under the sphere is 2. You've got 3, 4. You can change the order by changing the number, and it will swap them around. You can also add and remove these points quite easily. And another really cool thing is you can animate any of these values here as well. So two great ways to control your D-spline are to parent it to another object, which could be animated, as well as actually animate these values yourself. Finally, one more thing to cover with the D-spline is these front handles here. And these control the facing angle of the D-spline at the start of the spline and at the end of the spline. So in the example here, we had the, if I just find our particles, I'm going to go look from the top view. Our particle emitter is pushing that way like that. And the D-spline, you can control this handle so that the front of the D-spline will be facing that particle emitter, and that kind of sets your initial direction of the D-spline and then the direction as particles exit the D-spline. So by going into edit mode, you can select these handles, but a second tip is that when you are moving these handles, the direction is sometimes inverted, which can be really confusing. So right now I've selected the X handle, and you can't move this in and out from the spline, so instead it's going to be moving it up and down. And this can be pretty confusing at times, especially since you can't undo any movement. So that's, again, when you're moving this initial thing, facing angle, you should save your scene first, just so that if you make a mistake, it's very easy to revert back to the original scene here. In previous versions of RealFlow, it seemed to be a lot more buggier, but every version it seems to get even better and easier to control. So this is an overview of the scene and of the D-spline daemon itself. The D-spline really is a game of give and take. So it's a tug of war between finding a nice balance between the three main strengths, vortex, axial, and radial, of both the control points and the D-spline as a whole. And if one of these strengths is too strong or too weak, things just aren't going to look right, and your fluid is going to misbehave or have problems. But luckily it's fairly easy to identify what settings need to be adjusted, and the easiest way to do that is by making play blasts of your simulations. So this is a series of 3 play blasts of this shot over the course of our project, and we did many. This is one of the earlier ones, and you can see in this simulation here that the fluid was at least kind of making it through the D-spline, but we lost it. Basically, after this main curve here, it had trouble kind of getting up the D-spline, and then at this point here, all 3 strengths are pretty much just way too weak. But on the contrary, back at the start of the D-spline, our strength, especially the radial strength, was way too strong because the fluid holds together perfectly, even with a few noise demons in the scene to try and break it up. The fluid holds together perfectly, and it's pushed right into the middle of the D-spline. See how big the radius of each of these points is. The fluid still doesn't get anywhere near the edge because the radial strength is too high. So in our second attempt, we tried a few things. We tried animating the circle emitter, and so that way the fluid kind of came in over time at different points of the D-spline, which, if the D-spline's got 3 forces, radial and axial and the vortex, having the particles come in at different points of the D-spline will create variation. We also put in a few just standard geometry from RealFlow with the aim to break the fluid up into 2 separate streams. And so as the fluid went in, here you can see it was a bit better. As it got to the end, it held together a lot better around the corner here, and it's got to the end, although there's still a few problems. The main issue of this take here is our axial strength was not strong enough. So you can see the fluid has to climb up the D-spline at this point, so it's fighting against gravity to get up and along that D-spline. And over time, the fluid kind of bunches up and clumps together here, and so the force of the D-spline along the axial strength is not strong enough to get the fluid up the D-spline, so it's kind of like pushing back down the wrong direction, and it gets clumped up. And again, compared to our first take here on this corner, this is kind of too strong, so we probably want to go halfway, because you want to have a bit of a breakup in the look we were after, at least. So this third one here is one of the final ones, very close to the final one that we used. And you can see here that the fluid breaks up a whole lot, and you would probably say that this is too much. You can see that as it gets to the corner here, the whole bunch here just, the forces of gravity just push the fluid out of the D-spline, and you just lose it all as it drops down. And so we made sure that our K volume was pretty large in the scene, so that if fluid did fall out of the D-spline, it would still continue on for a while instead of just, disappearing and getting cut up by the K volume. That way it still looks pretty realistic and it still looks interesting. Imagine if this fluid here fell off the D-spline and then just disappeared. It wouldn't look good. But we definitely want the K volume to be big enough so that if some of these particles here that aren't needed get off frame, they can be deleted and reduce the simulation time. So apart from the particles that are falling off, the fluid here looks a lot more interesting. It continues along the length of the D-spline pretty well. Here at the start, the wave that the vortex creates is pretty interesting. We've got two streams here pushing against each other. They do push through the main rays of the sun. And the main reason that we kept this take here, or one that was close to it, was because even though from this view here, we've got a lot of particles that fall off screen, in our final cropping, like this, you can see that we don't even see those particles that do the corner. And so even though all those particles off screen here are kind of dying, in the final animation, they still look pretty interesting. So this is an overview of this particular shot and how we approach this scene in RealFlow using the D-spline daemon. We've loved using it and have definitely learned a lot from the community over the course of the project. So we hope that this video is also useful to others. So happy simulating. Be sure to check out our Real Pictures website and Facebook page. We're hoping to put a few tips and tutorials for RealFlow, 3ds Max and V-Ray onto the YouTube channel. And if you have any questions about this particular scene or RealFlow, D-spline, please post them in the comments section of this video's YouTube page. Thanks.